Okie dokie. Let's see. All right. 100 ml sample. This is, by the way, practice test 9 video 2, problem 12. 100 ml sample of a solution with a concentration of 5 molar is diluted by adding 300 ml of distilled water. The new concentration will be, okay, this is a dilution problem. Volume of concentration, molarity of concentration, volume of dilution, molarity of dilution. Okay. Plug in all of your numbers here. 100 ml sample of a solution with a concentration of 5 molar is diluted. So this is your concentration. 100 ml sample, and your molarity is 5.0 molar, is diluted by adding 300 ml of water. What will the new concentration be? We're solving for this one right there. So we got VC MC over VD. Okay, and that equals the molarity of our dilution. In this case, let me zoom in just a little bit. Okay, in this case, it's going to be the following numbers we're going to plug in. Okay, volume of concentration is going to be 100 mils times our molarity, which is going to be 5. I should really be including my units here. I'm not, just because I don't have a lot of space. And volume of dilution is 300 mils. 300 mils. Okay, so 100 times 5 divided by 3. So that's really going to be 500 divided by 300, right? Well, I'll just do it like this. 100 times 5 divided by 3. No, sorry, by 300 equals 1.6. 1.66. Letter B is your answer. Okay. Number 13. What is the name of this acid, HNO3? You should know that. It's it's nitric acid. Okay, HNO3 nitric. Which of the following substances is a base? Calcium hydroxide, H2O, H2SO4, and HC2H3O2. Okay, H2O is water, H2SO4 is sulfuric acid, HC2H3O2, well, that's acetate, and you got an H in front. That's acetic acid. The only one that's a base is calcium hydroxide. Dead giveaway right there. Hydroxide. Okay? A metal hydroxide is a base, usually. A substance that turns cabbage juice blue and only slightly lights up a light bulb is a weak base. Why? Because it turned it blue. If you turn it red, then it's going to be an acid, or pink. It's an acid. If it only slightly lighted up a light bulb, then it's a weak electrolyte, not a strong electrolyte. So what's it going to be? A weak base. Letter D, weak base. Number 16. According to Arrhenius, acids are often substances that... Arrhenius said that acids are the substances that increase the concentration of H+. We can go through and look at the other stuff here, but definitely not decrease the concentration of H+ or decrease the OH. Arrhenius described acids as things that increases the concentration of H+. A solution has an H+ concentration of 1 times 10 to the negative 4 molar. What is the concentration of OH? Okay, so you can solve this a couple of different ways here. Well, the first thing you should do is you could go to pH. Your pH, therefore, is going to be 4. pOH is going to be 4 minus 12 minus 4. 12 minus 4 for a grand total of, 14 minus 4 for a grand total of 10. Okay, so your concentration of OH minus concentration is going to be 1 times 10 to the negative 10. 1 times 10 to the negative 10 is what your OH concentration is going to be. All right, that's going to be letter B. What is the hydrogen ion concentration H+ of a solution in which the pOH is 9. Okay, so if the pOH is 9, then your concentration of OH minus is going to be the following. Oh, I'm sorry, you don't even need to do that step. You can say pH equals 14 minus 9. So 14 minus 9 is 5. Okay. So again, remember, if you got pOH and you want to find pOH or vice versa, you just take that number and subtract it from 14, which is the pH scale. Okay, so your pH is 5. So to figure out the H plus ion concentration, all you have to do is take that number and do the negative log, which ends up being 1 times 10 to the, take that number, turn it into a negative exponent. 1 times 10 to the negative 5. That's going to be letter A. Very simple. Okay. Number 19. Which of the following solutions may have a pH of 8? pH of 8 is basic, right? So if it's basic, it's not going to be acid. Rubbing alcohol is going to be neutral, and vinegar is an acid, so it's going to be ammonia. Ammonia is our base. Okay. Okay, number 20. This goes back to our notes, the last set of notes we did, 9.3, where it talks about naming. Okay, so hydroiodic acid, you got to work backwards. Remember, if the anion ends in IDE, anion is IDE, anion, then that's when you have this hydro blank-ic acid. So if the ion ends in IDE, which in this case is iodine, which is iodide, iodide is the anion. Okay, so you get hydroiodic acid. That's just HI. That's your formula. Okay, ClO3. Okay, ClO3 is chlorate. Chlorate. This is chlorate, right? Chlorate. That's your anion. And if it ends in ATE, then your acid is just going to end in IC. So this is chloric acid. Chloric acid. Acid. Okay, that's how you do that one. Okay, number 21. What is the concentration of a solution when 0.4 moles of KBr is used to prepare 600 mils of solution? Hey, this is an easy one. They're just asking you for concentration. Concentration, remember, is M equals N divided by V. Number of moles divided by your volume. In this case, you got 0.400 moles of KBr prepared 600 mils of solution. Volume should be in liters, by the way. Volume in liters, okay? 600 mils of solution is actually 0.600 liters. So 0.4 divided by 0.6. Gives you a grand total of 0.6666667. So 0.667. How about, let's say that. 0.667. There you go. That's going to be big M, molar. How many grams of calcium nitrate is needed to prepare 120 mils? You know what? Let me just go ahead and start a new video. Okay, I'll start a new video right now.